Hello everyone, welcome to Intro to Machine Learning. This is lecture 7, and in this lecture, and rather with this lecture, we'll begin building our models. The first model we are looking at is a simple linear regression. So you're going to learn about what is regression, a little bit of mathematical notation, not too much because this is a beginner level course and a beginner level video, and then we'll also learn how to fit a line into your data. We look at a real world data and then finally a Python implementation of that. Okay, so what is regression? By definition, it's a mathematical technique to determine relationship between two variables. So essentially, we are trying to figure out, in general, how much an independent variable has an impact on the dependent variable, right? And that how much is utilized to predict something that's unknown, right? Okay, so how does that work? One way of thinking about it is why don't we just like plot that data? So for example, we are looking at the pricing data. So let me talk a little bit about the data first before going forward. So this is the link to get that data. I simply Googled and I got Kaggle. It has house sales prediction. This is from a specific county for a particular year. So it has around 22,000 observations. That means 22,000 rows. And I'll show you in a while how it looks like. All I've done here is that I've picked 10 or 11 points or 10 or 11 rows from the data and just two columns. So the first column is the square feet or the size of each house, and then the prices in US dollars, right? So I just picked up two columns and just got 10 data points, as you can see, and plotted them. So as you can see, for a given size, let's say 1,000 square feet, the value of that house or the price of that house is somewhere here, which is about 300K, sorry. So, and similar to that, like I have other values as well, right? So I just picked up like 10 data points and I plotted it. Now, the problem here is that let's say I have a square, a house of size 750 square feet, right? And I'm trying to predict its price. Like what price can I get when I put it on sale? Right. So multiple ways of doing that, as we said in video 1. Now we're looking at a more systematic way of solving this problem. And one way of doing that is to imagine drawing a line that runs roughly through the middle of this data, right? So having a line somewhere here. Right, so if I could do that, then whatever the size of the house, I can see where that size points to, and then I can predict the price of that size house, right? So this is exactly what simple linear regression is. How with one variable we can develop or actually create this line that will help us predict things given this independent variable, which is size in my case, right? Okay, so if you think about like a more mathematical way of like imagining this line, you know that this is the equation of a line. So y equals sum y equals m of x plus c, right? So this is the equation of the line, and this is what we want to draw here, right? So there's certain terminology essentially associated with this. So m here will be the slope of this line, and c will be the intercept, right? So this is my intercept, and this is my slope. Now, let's go to the second slide and see if we can get this line. So and we'll see in a short while how to implement this in Python. But for now, okay, so I think I missed this. This is square feet, and this is price, right? Just to avoid confusion. Okay, so I have this line, right? And the equation for this particular line that I got was y equals some 100,974 plus 153.4x. And our goal in this video is to determine to get to this point, right? So now I know that the equation for this particular line for this housing price data is this. So I got this from Excel. We'll get it in Python as well, right? The meaning here, like I want to focus on the meaning. So the meaning here is that if x is 0, right? So if I have a zero-sized house somewhere, still I'm going to get a price of $100,000. So that's my predicted value, right? I may or may not get, but that's the predicted, that's the meaning essentially, right? So these regression coefficients, these numeric values are estimates of the unknown population parameters, and they describe the relationship between my x and my y, right? So what is my y here? My y is my price, right? And my x is my square feet. So this is what our goal is, to get this equation, and we'll see how to get this equation, right? So what is this this equation and how do we get it? So there are many ways, and the most the simplest possible way of getting this line is to imagine that we are trying to minimize the distance of each point here with each of these points that are scattered around. Okay, so this might sound a little bit hazy, but let's see what this exactly means. Okay, so we're using this technique called ordinary least squares. So let me draw this again. Maybe I should have put the graph here already, but let us assume we have these prices here, right? So this is 100K, 200K, 300K, and so on, right? And then I have the square feet, let's say 500, 1000, 1500, and so on, right? And let's say I fit this line here, and then these are my data points around this line, right? Now, if you look at these points, so let's say at 1000 square feet, right? At 1000 square, or maybe let me look at a place where there's a single point. Let's say there's a point here, right? Okay, so at 1500 square feet, right, my predicted value for the house, or the price of the house, is around, let's say, 300, right? So this is my predicted value, but this is the actual data that I have, and this is around, let's say, 320, right? So the way I'm going to do, so this is the actual value, which I'm going to denote by y of I. So this is my actual value, and this is my predicted value. And if you're getting confused with I, this is the IS observation. We might or might not get into it right now. So let's assume we are denoting it by y, and then the predicted value based on my regression equation is y hat, right? So this is my predicted value. This is what my line predicted, right? This is what I'm going to predict. So essentially, the way ordinary least square works is that I am trying to minimize this difference between y and y hat, right? So there exists this difference between actual and estimated, right? And then this difference is going to exist for each of these data points here. Now notice, right? So my goal here is to get these differences in such a way that the sum of all these differences for all the y, so now you know why I comes from, like each of these point is an I, right? So I'm trying to minimize this, right? So I'm trying to minimize the sum of the squares because I'm only interested in the magnitude and not the negative and the positive sign. And so I'm trying to minimize this. So here my objective function for this problem is to get the min of the sum of I starting from the first to the nth value, assuming there are n values, and y of I minus y hat square. So my aim is to draw a line that minimizes this difference. So I have to get the predicted values for each of these such that the sum of the difference from the actual and the predicted and the square of those, so essentially the magnitude, is minimized. And that's how I get this regression line, right? Okay, so this is how we approach regression in more from a mathematical perspective. Now let's go and check the data, how the data looks like, right? So as I said, let's keep this. So as I said, I downloaded it from here. So it's kaggle.com, and then this is what it looks like, house sales in King County, USA. And on the data page, you can go in and hit this button and you can download the data. Right, and this is how the data looks like. We are going to use it when we talk about multiple regression, when we use multiple variables. But what I did was I simply copied this row, this column C and column F, because this is square feet and this is prices. And then I created a new CSV file here and I named it simple underscore regression underscore data. And also notice that I took just the first 100 values. And why I did that was because this will make a lot of things clear for us going forward. And then when we go forward, we will actually use the entire data set. But for now, just to understand things better, I took the top 100 values. That's it, right? And I saved it in a new file because we're doing simple linear regression. We just need two variables, one dependent, which is price, and the other one is independent, right? Okay, so let's go ahead and implement this in Python, and I'm going to go here. I have certain things already here in my code. Now this goes back to our previous lectures, right? We have looked at this before, how to import libraries. So this is what this does. Let me import them. So we are familiar with how to import libraries. In this one, we are using NumPy, Matplotlib, and Pandas. Let me import them. Okay. So this is from previous lectures. If you're not clear, just go back and get that. This is data import. So here I'm going to import my data, which is saved as the file called simple underscore regression underscore data.csv. So I imported it. These two lines have the independent and the dependent variable. So my dependent variable is y. So it depends on how you've saved it. For example, it is the second column, which is why I'm taking that right here. And my x is the first column, so that's why I'm taking it as it is. These two colons, if you remember from the previous lectures, represent take all the data, take all the rows. Okay, so that's that, x and y, and then I did a train test split, and what I did was I took a test size of 1/3 of the entire data. So this is going to be about 33 values as such, right? Now we have to talk about, we have to get the model working here, right? So this is the first in this series of videos in which we are actually getting to train a model, right? And the Python library that you're using is again scikit-learn, and the way we do that is sklearn dot linear underscore model. So this is the module from which I'm getting a particular class that's going to help me implement this regression line, right? So that particular class is called linear regression. Okay, so this is how I'm going to import it. The next step is go and create an instance of this class. So this is common. You can name it anything. I'm naming it regressor, or maybe let me name it linear regressor because we're going to create more going forward. So let me name it linear regressor and simply go and create an instance of this class, right? So Control C here. Yeah, so that's that. And then the next important point is that we have to fit and basically create a relationship between the data using this fit method. So you'll use this fit method throughout, even when we work with other more complex models, you'll use this fit method, and I'm using it for the first time now. So all you have to do is the object that you created is going to have that method there for you, right? So you've already created an object of the type linear regression. Just do a dot, you'll get this, right? And because, as I said, it is going to create a relationship between this linear regression class and your data, right? So obviously you have to specify your data here, right? So the first thing that you will do is x underscore train. You know, this is the training set. This is on which my model is going to be built, right? So this is how the regression line will be built, and then based on that, I'll do my predictions, right? And then y underscore train. So this is my response, right? So y train will have the prices, x train will have the square feet, right? So let's go and execute this. Okay, so as I said, there are 100 values, and okay, so why did we get that error? Okay, yeah, great. We have to execute the entire thing. I'm not sure if we actually input everything. Let's, like, to be extra sure, let me execute everything, right? Even before we move forward. Okay, so here we have this got created, this linear regression got created. Now the whole point of creating this was to predict something, right? So let's go and predict that. So we have to predict results for the test set. That's why we did this split here, right? So in order to do that, I have to create another variable, and that will be different from my y test, And why is that? Is because the test has the actual values for those test test examples, right? And my y pred, all the predicted values, will have what my model predicted, right? So that's why I'm creating a new sort of variable, right? So y pred is going to take the output of linear regressor, right? And do a dot predict. And what you want to predict on is your training set, test set, right? So training set helped me create the model, and test set will help me predict things, right? So in ypred, I'm going to have my predicted values for this test set, right? So let me see. Okay, so we haven't we have done a lot of things. We haven't really seen any output as such, right? So the first step here, in order to see the output, is to go and visualize that training data and test data and see how well my model fits. We'll talk more about how well the model fits in some of the later videos in the course when we talk about evaluation, right? So for now, this video is aimed at making you familiar with how to create models, how to visualize your results, right? So here I'm making use of matplotlib for the first time. So this is again a library for visualization. So plt.scatter is the method that's going to help me visualize the entire data, right? So the entire data, is x_train, and I mean only the training data here, right? So that's what the comment says, right? The second one is y train, right? So test train, y and x both. Okay, so I named it like weird. And then so this is optional, right? Otherwise it's going to take some default color. I want these data points to be red so that I can differentiate between the data and the regression line. The regression line is going to be blue, right? So this is what I decided. Obviously you can go ahead and do whatever suits you, right? So now the next is to plot the model that I created. So for that we use plt.plot. So what is that model that I created, right? So I have to visualize that in terms of my training data itself, right? So the first thing that I have to enter here is the training data, right? And then what is that model that I created, right? That model that I created is actually this, but that's based on the training data, right? So let me go and get this. And instead of test, I'll write train, because notice I'm trying to visualize training data only, right? So this particular line, linear regressor.predict, is going to give me that regression line that was created based on my training set, right? And then again, this is optional, but I just want it to be blue, right? So I'm giving that. And then I'll have obviously the X labels and the Y labels and all of that. So I have that option of making my plot look better. So maybe I can have the title, that is the header sort of. And what do I want to have there? Maybe price versus square feet, right? Versus square feet. And maybe I can write training set, because this is the training set. And this is what I want in the title. And then what do I want in the X label? So my X label, remember, is the x-axis, and that's my house size, right? So I can give that explicitly here by doing plt dot x label, right? So X label, and in string format, obviously you have to write house size in square feet, right? And then similarly, you can have plt dot y label. Yes, that's what it's showing me already. Oh, oops, this is funny. House size. And finally, you need price in dollars, right? So price in dollars here. And finally, after all this is done, you have to do a plt.show so that it shows this plot in my console, right? So let's visualize training data and see how it looks, right? Okay, so here we have the plot, right? As you can see on the right hand side, there is this blue regression line that's fitted into my data. And this is the line, if you go back to our definition of the regression line, that has minimized the distance between each of these points and this line. So essentially the square distance this is the best fit, so to say, in terms of minimizing our objective function, which was this. Right, so this is our regression line. You can visualize that. You can visualize test data as well. So let me just like copy this entire thing. And a small change that I have to do here is instead of doing an X train and Y train, I'll do an X test and Y test, right? And the rest of the stuff stays the same. Why? Because my model stays the same, right? So I have to see how well this is predicting my values. So I can actually visualize that here, right? And instead of training set, let me write test set, right? So this looks okay to me. Let's go ahead and do this. Yeah. Okay, so notice here, this is my regression line and these are predicted values. So these are the actual values and this is what I got in prediction. So as you can see, there is a lot of, there are a lot of points that actually lie on the line. So for those houses, the prediction is quite accurate, but there is a lot of difference for other values, right? And obviously it depends on the data and we'll talk more about it in evaluation. But for now, a small, um, something that I want to talk about more is what if you want to predict for, let's say, a house whose area is 750. You want to predict a price for a house that has of size 750. It's not quite evident here, and we can do that using an additional line of code that's print and then the name of the model that I created here, which is linear regressor, right? So let me copy that, right? And I can use that to do a linear regressor dot predict. And then within the predict parentheses, you have to give a two-dimensional vector. Now I'm trying to predict for a single house, so I'll have to use two square parentheses, right? So I'm trying to predict what is my model telling me about this house, right? A house of size 750 square feet, right? Let me see. What did I forget? Okay, I think I forgot this. Let me do that again. Yeah, sorry. Yeah, so this is the output that I get. So according to my model, for a house of size 750 square feet, the predicted price is around 217K, right? So this is how you can use your model to get that exact value for a particular prediction that you're looking at, right? The other way is obviously you can read through the data itself, or you can read through the plot itself. Another additional point that I want to make here is that remember this equation that we are trying to come to, right? So essentially we are trying to get to these coefficients. One way of getting the exact coefficients for this particular data, for this particular model, is to go ahead and again do a print and then whatever your model is, which is linear regressor in our case, right? And you can get the exact coefficients. So linear regressor dot coef underscore, and if you print this is my coefficient for that equation in which I was looking at m, right? So this value is this, right? So this is the slope of that line, if you think about it, right? This is the slope of that line, and then if I'm trying to get the constant here, which was my, if you look at this equation, which was my c or the intercept, for that all you have to do is again get this. And instead of coefficient, you can write intercept and you can get the intercept. So now from this, you can imagine the equation looks like price in general is equal to this times square feet, right? Plus this. So I got my regression equation here, right? So if you really think about it here, let me actually write it down to make things clear. If you look at both of these, my equation here is that my price is equal to 236.8 plus 3, times 2 times x, which is square feet, plus this 39843. So according to my model, if the square feet of my house is 0, I'm looking at a price of $40,000, right? And then with a unit increase in my, so notice now this coefficient here is my slope, This is the slope of my regression line. So for every unit increase in square feet, this is the price, this is the increase in price. So remember that. So this is what it means. With every unit increase in my square feet, if you imagine this plot, with every one increase, this is how my price is increasing. This is what it means in real world terms, right? So this is how my price is increasing, and also this is an easier way to visualize how my regression line is fitting into my current data, right? So with this, I end the discussion on regression. In the next video, we'll talk about multiple regression, in which what we'll do is we'll utilize all the columns in this data set and try to build a model and evaluate that. Okay, thank you.